Morning. So my name's Chris Baldwin. I'm Operations Director here at Europa Nursery in Ash. You can see the glasshouse behind me and the other glasshouse up there. That's 12.4 hectares of greenhouse, which is about 14 football pitches. But I've been asked to talk about the other elements, sort of the other disciplines that are applied here as well. So obviously it's a big manual job, lots of plants to look after, so we have 100 staff on that. However, the building behind me here, I'm walking there now, so this is our energy centre. We work in partnership with an energy company, and we are burning gas in Rolls-Royce CHP engines, which I'll show you. So effectively what we're doing here is we're burning gas and generating electricity, but when you burn gas you're also getting carbon dioxide and you're also getting heat from the engine. It's quite loud in there, so I'll say a bit more before I go in. So this CO2 that's produced from the engine goes into the greenhouses and the plants absorb it. So essentially you've got green energy generation, because the nasties that are being produced in carbon dioxide and heat are not being put out to atmosphere, they're going into the crop, and then through photosynthesis the crop is taking on the CO2, making more assimilate, making more fruit, more growth. So that's our gain. And the electricity produced is locally in-fed electricity, so it goes to well, it goes to Sandwich, but it goes to local towns, and it supplies energy for about 15,000 homes. The CO2 produced is about 3 tonnes per engine per hour. We've got 2 engines here. They're both 7.5 megawatts. So you might lose the sound, but I'll walk in anyway and explain. But the point of this really is saying, you know, we're growing tomatoes, we're close to you, but there's a lot of disciplines that are required as well. So, you know, highly skilled engineers here, and when you see the kit that everyone's looking after, then that might help explain. So I'll go in now, and like I say, you might lose the sound, but at least you'll see what I'm talking about. Okay, so I'll switch round. So there's the engine. This is a 7.5 megawatt Rolls-Royce engine. It would normally drive a ship, so this end here, so that's where the generator is, but normally what there would be is a propeller on the end. So instead of a propeller, there's a generator. That generator, so magnet and copper coil, so that's spun effectively off of these cylinders and pistons that are sat inside here. So it's a 16 cylinder engine, and it's 750 explosions per minute, and it all happens so quickly. The gas is actually ignited on its way in to the piston. It happens that fast. So there's a pre-chamber gas valve where the gas is ignited, the explosion occurs, the piston's pushed down, turns the crankshaft, which turns the generator at the end. Then at the back of any engine you've got the exhaust. So they're the 2 exhaust pipes. I'll just nip outside the door and show where they go. It's quite hard to see, but essentially they go down the building where we capture the heat and we capture the CO2. So those pipes are holding temperatures of about 380 degrees Celsius. So you can see the 2 pipes running next to me. They drop down into this big unit here, and in there it's like AdBlue that you get into in cars, and this is about cleaning all the gases, taking the nasty noxious gases out, and then we're just left with CO2. Goes through all these cleaning blocks into this pipe, and in this pipe there's a honeycomb selection of pipes going that way with water in, and then there's the hot air going that way, the 380 degree air, and that is where the temperature is absorbed into the water. So it comes down that pipe, along, back up that pipe, and then out to our heat storage tank. So that happens in this system here, and we drop the temperature effectively from 380 degrees down to 38 degrees. So now we come into this is a CO2 manifold, and then there's fans here, and these basically suck the CO2 out of that manifold and blow it into the greenhouse. So So that's where we got 6 tonnes per hour of CO2 in there. If this wasn't a greenhouse at the end, it would simply go up the chimney and out the stack into the atmosphere. But we've got a greenhouse and we've got 500,000 plants waiting for that CO2. So going all the way to the end of the building, these are all our heat manifold valves. So this is basically determining what temperature of water goes into the greenhouse. That's how we heat our greenhouse. That's the hot water effectively that's captured from those gases. This is a backup boiler as well. So other than just generating electricity, we can just generate heat for the greenhouse as well if needed. But the engines that are generating electricity provide us enough heat. Bit of a whistle-stop tour, but finally out this door here, there's a heat water storage tank. So this is where all the hot water goes when we don't need it for the glass house. And this is 5.5 million litres of water. See, just a big water tank really. And there's the greenhouse again. Okay, thank you.